Oversensitive. What do I mean by that? That will be clear, of course. You have heard today and also in earlier meetings about climate sensitivity. And my talk is about climate sensitivity. So how sensitive is the climate to CO2? And okay, a little bit about myself, because it's the first time that I'm speaking here, and it's really an honor to be here. I was last year in Mannheim at the conference as a visitor, and well, I am a science journalist, and I used to work in Holland for a magazine which you can best compare with Bild der Wissenschaft. So it's a popular science magazine, but quite serious. And so I used to cover lots of topics, not only environmental topics, but also medicine or whatever. And then in 2005, I worked, my editor-in-chief said, yeah, there is something going on with a hockey stick or something, and you have to look into it. And so I had to look into this hockey stick, and I never wrote about climate. So I was completely neutral. I was not a skeptic, not an alarmist. I was nothing. I was blue. And so I asked, what you normally do as a science writer, you start interviewing people about this topic. And so I went to KNMI, our weather service, and to universities. And I asked everybody, what about McIntyre and McKittrick, these Canadians that criticize the hockey stick? And everybody in Holland said to me, oh, don't take them serious, they are no climate scientists, and etc., etc. And then I also saw that Hans von Storck from Hamburg also wrote an article criticizing the hockey stick a bit. So I thought, okay, this guy is interesting. So I took a train from Amsterdam to Geesthacht, and I met Hans for a day, and I asked him the same question. What about this McIntyre-McKittrick? And he said, well, I think that their paper, their criticism, should have been published in Nature. Because their original article was published in Nature, and McIntyre-McKittrick tried to get their criticism in Nature as well. So I thought, okay, if this guy takes them serious, I should take them serious as well. So when I came back in Amsterdam, I sent an email to McKittrick, and he said, well, you should talk to McIntyre. So I made an appointment with McIntyre, and I had a phone call with McIntyre for 3 hours from Amsterdam to Toronto. And after that I was, whoa, what a story this is. Yeah? But it was very difficult because at the time they hadn't yet published their criticism in a peer-reviewed journal. So if I would go out, then everybody would start criticizing me. Oh, it's not peer-reviewed, it's blah, blah, blah. So then we worked together. And in the end, their paper was published in GRL, Geophysical Research Letters. And so I was working on my article, and I was even checking with an independent statistic in Belgium, who is an expert in this principal component analysis. And she confirmed that the criticism of McIntyre-McKittrick was completely valid. And also Hans von Storck confirmed that this part, McIntyre-McKittrick were right. So then I came out with this article, very long article, 5,000 words, 12 pages in our magazine. And we translated it into English, and it was published in a Canadian newspaper. And so we criticized the hockey stick in my first article on climate ever. And from that day on, everybody in Holland started calling me a climate skeptic. And I was completely surprised. Wow, I worked for 2 months. I worked for 2 months on this article, and I knew that I was right, and I knew that McIntyre-McKittrick were right. And so I thought, okay, what's going on here? This doesn't look good. You know, as in Holland, KNMI was using this graph for many years. So then I continued working on climate, and I noticed that at my work I was just following all the blogs, and I couldn't work on other topics anymore. So I quit my job, and then I worked for 2.5 years. I worked on a book, and that's this book, and it came out in 2010. Unfortunately, it has only been published in Dutch. But I continued working on that, and after this came out, to the credit of the Dutch government, I criticized AR4, the fourth assessment report of the IPCC, a lot in this book. I document that IPCC is ignoring skeptics, or they are like They're mentioning, okay, this paper by a skeptic, it was completely debunked or whatever, you know. And so I document this, and then the Dutch government gave me money to review AR5. And they also gave me money to set up an international discussion platform. It's Climate Dialogue, climatedialogue.org. It's now, yeah, it's still, the content is still there, but it's not active anymore. So, that's a long introduction, so now I have to speed up with the climate sensitivity stuff. Okay, what about climate sensitivity? Climate sensitivity, is by definition, if you double the CO2 concentration, how much warming do you get? And the equilibrium, climate sensitivity, ECS, that is the warming after the system has become in equilibrium again. So, and starting from the Charney report and all these IPCC reports, the range was almost always 1.5 to 4.5. And the best estimate was most of the time in the middle, 3 degrees or 2.5. In AR4 it was still 3 degrees. And now it comes in AR5, when the IPCC was more certain than ever, yeah, it was extremely likely that most of the warming is due to humans. They say about climate sensitivity that they didn't give a best estimate. And in the preparation, I was an expert reviewer of the report, and what was really intriguing was that in the summary for policymakers, so I don't know if Herr Puls is still here, so there was something said in the summary for policymakers, but they did it in a footnote. So you have to go to footnote 16 in the SPM, and there it was said, no best estimate for equilibrium climate sensitivity can now be given because of a lack of agreement on values across assessed lines of evidence and studies. This is typical boring IPCC language, yeah? But you can imagine that something is going on. I mean, climate sensitivity is arguably one of the most important parameters in the whole climate discussion, because it determines how sensitive the climate is, so how much warming will you get in the future if CO2 continues increasing, which it will likely do. So, and during the preparation of the report, I got to know this guy, Nick Lewis. He's a British independent scientist. He's a very interesting guy, and I'm really happy that I worked together with him on a report. That is this report. It came out after the IPCC report. Nick Lewis is a mathematician, and Lewis knew, of course, about this whole hockey stick thing, and he thought, okay, McIntyre is already doing hockey sticks, so I better pick another topic, and climate sensitivity is very important, so why don't I look into this climate sensitivity business? So he started refreshing his mathematics and statistics, and he started digging into the literature. And so Lewis and I at the Global Warming Policy Foundation, last year we published this report. You can download it from the website. If you just Google on the title, you can freely download it. And you can see it's a sensitive matter, how the IPCC buried evidence showing good news about global warming. The fact that we said buried evidence, that was enough already. Everybody who worked on IPCC hated our report from the start, just because of these two words. Maybe it was not smart to do it after all, but the report itself is very factual, very factual. It's a long, very technical, but also very factual. It's not emotional report. Okay, so historically, we have to go back a bit. You saw this table, and historically, the estimates for climate sensitivity were always based, always based on GCM, so on the climate models. And really soon already has shown the many problems with the climate models. So this is a bit tricky, that we have to base our estimates for climate sensitivity on the models. So you would prefer a second method, an independent method, which you can use to check the models. And this is exactly what has happened. There is this guy, Jonathan Gregory from England, and he is very mainstream. He's a good scientist, he's very mainstream, and in 2002 he came up with this article with colleagues, and in which they describe a second method. And it is an observationally based method. So they use observations to estimate climate sensitivity. That's great, because then you have an independent check, like they said in the article. Because the method does not use the climate sensitivity simulated by a general circulation model, it provides an independent, observationally based constraint on this important parameter of the climate system. We fully agree. We fully agree with this. So, how does this method look like? This is about my only formula, don't worry. Here is climate sensitivity. Here is the temperature change, the global temperature change. This is the change in the forcing, so it's mainly greenhouse gases and aerosols. And this is the heat going into the ocean. And this is the forcing, which is correlated with a doubling of the CO2. And that is, IPCC uses the number 3.7 watt per square meter for that one. And so, these numbers, what is great is that IPCC is publishing estimates for all these three numbers. Yeah? So, suddenly, we can, with this method, we can estimate climate sensitivity based on observations. So before we go to AR5, the fifth assessment report, we show this graph. I show this graph from the AR4. These are estimates for climate sensitivity, and this is more or less the traditional view you can see. Here you can see 3 degrees. This is the best estimate they had. And what also is the case, that you have these long tails or fat tails. And fat tails, of course, are scary because it means that you cannot exclude a high value for climate sensitivity. You cannot exclude that you get sort of runaway global warming. And Nick Lewis looked into all these studies. And most of them, and we described the problems with all these studies in our report. Most of them have big problems. And here is Gregory O2, the one we just mentioned. And it's going here, and it's going a long way. Even at 10 degrees, you still have a probability that it can be 10 degrees. You know? And the best estimate of this study, you cannot see it here because it's cut off, but it continues even further. The best estimate of Gregory O2 is 6 degrees. It's even higher than the climate models. The climate models are more or less around 3 degrees. So the study of Gregory was fully accepted because it was like mainstream. But what Lewis did was he looked into this and he found that the Gregory O2 study, this one, he uses outdated data for the ocean. He uses the wrong forcing. So what Lewis did in a blog post, he corrected the Gregory O2. He updated the data, and then he already got this. You see, the fat tail is gone. It's much better constrained. And the best estimate now is more or less the peak, and that's at 1.8 degrees Celsius, and no longer 6. This is amazing how it changed. And you have this other one. This is actually the only really observationally based study that was in AR4. That is the Forster and Gregory, it's the same Gregory, the Forster and Gregory, which use the satellite, the data that Willy Soon just showed you about the energy fluxes at the top of the atmosphere. They use this directly to estimate climate sensitivity. And you can see this here. This is the Gregory Forster, but this is the original result, like they published it in their paper. But IPCC made an error. They had to transform the axis, and by doing this, they changed the result of the study into this. So suddenly, it has, again, a fat tail. And Nick Lewis actually discovered this, and he sent an email to Gabriele Hegel. Willy Soon was mentioning her, and he pointed this out in a blog post on Judith Curry's website. And he said to IPCC, you have to correct this. You have to correct this on your website. And guess what? They refused. They refused to correct this. So, we go to AR5 because there is some excellent news in AR5. And what was it? The good news is this. You are not going to guess it. This is in the SPN. The total anthropogenic radiative forcing, the forcing, best estimate for 2011 is 43% higher than that reported in AR4 for the year 2005. Why is more forcing good news? That should be bad news. No, it's not. Here you can see it. This was in AR4. This is the probability of the estimate of the forcing. And it changed to this. What happened? Well, you can see from the method, if you increase the forcing, and in the same period between 2005 and between 2011, we had this global warming stagnation, so delta T doesn't change, and you have more forcing, then your ECS will come down. So more forcing with no more temperature increase is very good news. But that conclusion wasn't drawn in the SPN. So they gave the good news, they said we have more forcing, but they didn't say this means that climate sensitivity has to come down. They only mentioned this in this famous footnote. So now we can use the numbers from IPCC itself, and we just can fill in the formula. And here you have it. These numbers all come from IPCC itself. And with these numbers, you get an ECS of 1.66 with the numbers from IPCC itself. And you have to realize that this forcing, this means that all the warming since, let's say, 1850, all the warming is due to greenhouse gases. Because the forcings of IPCC assume that solar, for example, doesn't play a role. Yeah? So this is mainly greenhouse gases. So if, for example, Willy Soon will never accept this, of course, yeah? He will say, this is bullshit because I don't accept the forcing. Yeah? Okay, then you can just say, okay, well, let's say that only half of the 0.8 degrees Celsius increase was caused by the forcing and that the rest is solar or natural variability or whatever. Well, then you say, instead of 0.8, you make here 0.4, and you use the forcing and the ocean heat and etc. And then, of course, your climate sensitivity will come down further. But this is accepting everything from IPCC, and you already get only 1.66. And the lower bound, their lower bound was 1.5. So it's close to the lower bound. And so here you see, after we published our report, Nick Lewis and Judith Curry, they published this result also in a peer-reviewed paper. And here you see they use different periods. Yeah, you take a period in the beginning and a period in the end, and then you do the estimate for climate sensitivity. And you see that the periods, of course, give slightly different results, but more or less the same. All around is 1.6. So this is, of course, excellent news. But the problem for the IPCC was that their climate models that they use for the projections towards 2100, they have an average climate sensitivity of 3.4. So now we have an independent method, observationally based. It says it's 1.6. And we have the climate models on which they base most of their report, which have a climate sensitivity that is double the observationally based estimate. And this was a big problem, because many studies appeared. Here you see, these are so-called violin plots. Here, now you see the probability. This is the probability that it's, and the black one is the best estimate. So you see the best estimate all below 2. This one is slightly above 2. And this one, Otto et al., is very interesting because this paper was published before the deadline of AR5, and this includes about a dozen of AR5 lead authors. So they were fully aware when they were preparing the report that these observations show low climate sensitivity. And so you have now many studies, some of them after AR5, some of them before, and here you have the models. So here's the best estimate of the models, the average of the models, and here you have the best average, the best estimates of the observations. And you see they hardly overlap. Yeah? So this was their big problem that they had. And this is the reason that they put this in the footnote. They didn't want to highlight it. And that's what we document in our report in 60 pages. And of course they didn't like that. But it's really serious, because this shows that you cannot base your policy on the models anymore. I mean, and this is based on their own methods, still assuming all the warming is due to greenhouse gases. Now, there is this very interesting guy, Björn Stevens. He is American, but he is director of the Max Planck Institute. And here, what you see here is the aerosol forcing. Because the main reason, I have to go back a bit, the main reason that these estimates are now much better constrained, that you don't have these fat tails, is that IPCC reduced the uncertainty in aerosol forcing. Before that, they had to estimate the aerosol forcing, but they didn't have satellite measurements. So their estimates for aerosols were based on the climate models. So they used the climate models to estimate the impact of the aerosols. So this is like almost a circular reasoning. And so the main reason that this is now, that the fat tail is gone, is that the uncertainty in aerosols has become smaller, and also that the aerosol effect has been reduced. And that's what you see here. This is what AR5 is using for aerosols. It's still going down here, so this means increase in aerosol. But Björn Stevens is saying something like that if you go back to 1700 and you had this pristine environment, more or less, then the first amount of aerosols that you add to the atmosphere will have a huge effect. But later on, when the atmosphere is already polluted with aerosols, if you add even more, the effect will get smaller. And this is what is shown here. And what Nick Lewis did in a blog post was that he used the aerosol forcing of Stevens and said, what is the consequence for climate sensitivity? And then you get a similar plot. Oh yeah, what's also interesting, with the Stevens aerosol forcing, there should be warming in this period. You know, the traditional explanation for this period is that, okay, starting here, CO2 went up, but aerosol went up as well, and aerosol is the cooling, and the cooling was still dominating until this period. Yeah? But now with the Stevens forcing, already in this period, the greenhouse gases should dominate. So the traditional explanation for this cooling period is gone now. With Stevens, if you accept Stevens, it's gone. And Stevens, by the way, is very mainstream. He's very mainstream. He's good scientist. So, okay, so what does it mean for climate sensitivity? Now, the best estimate comes down to 1.45. And the whole range, the 5 to 95% range, is 1.5 2.2. It's outside the full range of the models. The models are between 2 and 4.5. Okay, I will speed up a little bit. You have a different form of climate sensitivity. It's called the transient climate response. The only difference is that now you don't have this ocean term. Yeah? And this gives you the warming. They say, people like Miles Allen in England say this is more policy relevant because if you double CO2 in 70 years, this transient climate response gives you the warming. This gives you the warming when you finish this period. So you double CO2 in 70 years, how much warming do you have? You don't have to wait for the oceans, you know? So they say this is more policy relevant. Okay, you can do the same calculation and you get, with the IPCC numbers, you get a TCR of 1.3. Now it becomes interesting, and here you see the same violin plots, and you see the models are 1.8 and the observations say 1.3. The difference is slightly less. So there is now some overlap between the models and the observations. Okay, I go quick. You have seen these plots a lot. So I've now explained that climate sensitivity of the models is almost twice as large as the climate sensitivity based on the observations. And at the same time, we know that already the models are quite dramatically overestimating the warming. So you say, okay, 1 and 1 is 2, you know. The models are too sensitive and they overestimate the warming. But this is something that nobody wants to admit in the climate discussion. IPCC will never admit this. This is the problem, so they have to come up with other things. So here you see the same. These are the models for the oceans, the global oceans. They warm up the oceans at a rate of 0.17 degrees per 10 years, and the data say it's only 0.09. And this is a really recent data. Here you already see the El Nino. Yeah, you know? And this is a plot of McIntyre. You see the trend, the model trend here, and here you see Headcrut. And you see that all the models in the since 1979, all the models are already outside the range of the observations. Okay, so their dilemma. What was the main defense of IPCC? Well, they have this graph in the report, and here is the range, 1.5, 4.5, and you see there are so many estimates. And in our report, we explain all these different methods, and we show what kind of problems they have. Yeah, here is the models. Combination is also using models. Paleoclimate is much more uncertain than if you use the observations since 1850. So you have to go back to our report. So we say that some of these instrumental studies, here you see Lewis and the Otto one, that these studies are actually at the moment the best indications of the climate sensitivity that we have. This is what we call the gold standard in our report. And of course they criticize it. Even, that was really funny, Jonathan Gregory, who was the guy who published this method, and he said, this is an independent method, yeah, observationally based. When our report came out, he said, well, you know, this method is quite simplistic. Well, he didn't say that at the time when he published it in 2002. So that was quite boring, this and also funny, this comment. Okay, so last 5 minutes. Future warming. Everybody in Paris is excited, of course. They say, you know, 2 degrees Celsius isn't possible anymore because our models say this will happen already very quickly. You can see that here. Right now, the emissions, this is the highest scenario, the RCP 8.5, and our emissions are even above RCP 8.5. Here you see the temperature, you know, this is not emissions, but right now the emissions are above RCP 8.5. So they say, you know, they regard this as a business as usual scenario. It isn't, it is more a worst case scenario in my opinion. But nevertheless, this scenario will cross 2 degrees is about here, 1.7. It will cross 2 degrees already in 2040 or 2045 or something like that. Yeah? So they say we cannot do anything anymore. We will cross 2 degrees. No way we can prevent this. But of course, this is all based on the climate sensitivity of their models, which is way too high. So can we do something different? Oh yeah, and this is also interesting. This is, in my opinion, this is the most influential graph of the last IPCC report. It's figure SPM 10, and it is showing the cumulative total anthropogenic CO2 emissions from 1870. So here you see all the CO2 that we have emitted, and here you see the temperature. And you can, from here is 2 degrees, and you can see that in RCP 8.5 is the red one, that already around here, yeah, 2040, that we will reach 2 degrees. And this is taken very far. They are talking about that oil companies are worth less. They are talking about stranded assets, that we have to keep the oil in the ground because we will cross the border, the 2 degrees limit, things like that. But it is, again, this is all based on oversensitive climate models. So what Nick Lewis and I did in our report, this is table 3 from our report, is we used the TCR, the observationally based TCR, and we coupled this to the RCP scenarios. And then we calculated how much warming you get. And then you see that with RCP 6.0, you get 2 degrees only in 2100, around 2100. And this, in my opinion, RCP 6 is quite realistically. If we continue like this in a business as usual scenario, this is quite realistic. So it's much more realistic to say that with our current understanding of the climate sensitivity, we can more or less, RCP 6.0, we will continue to emit as much as we do in 2015 for the rest of the century. We will not even decrease our emissions. And we will still reach 2 degrees only in 2100. Recently, very recently, Nick Lewis made a new version of the SPM10. This is the original SPM10. And what Nick Lewis is now doing is he is coupling his observationally based climate sensitivity, his TCR, but he is also adding a simple carbon cycle model. Because one of the big problems with the GCMs is they have this huge ECS, equilibrium climate sensitivity, and they have this relatively large TCR, 1.8 and 3.4. But the difference between TCR and ECS is heat going into the oceans. So what the GCMs do in the future is they put huge amounts of heat, of energy in the oceans, which of course will give sea level rise, but also and the next speaker will deal with this, if you add warming to the oceans, they can hold less CO2. So what will happen is that in the models will start releasing CO2 from the oceans in the atmosphere. So you get even more CO2 in the atmosphere. More of the CO2 that we emit will stay in the atmosphere. And this will amplify the warming. So this so if he couples this, then you get, for example, this is RCP 6.0 in 2100, and then you see that it is still around the 2 degrees Celsius. And this one, the green one, is RCP 8.5, but without the non-CO2 forcings, because what is very peculiar about RCP 8.5 is that it adds a lot of methane emissions to the atmosphere, and that's, in my opinion, and Nick Lewis as well, it's quite unrealistic. So if you only take the CO2 emissions of the RCP, then you would end up here. So the conclusion you can draw is that even if you assume that all the warming we have had so far since 1850 is all due to greenhouse gases, yeah, which is a really conservative assumption, then even then you will probably not reach 2 degrees Celsius before 2100. And it's really good news, and nobody in Paris knows this. They all live in this reality. This is their reality. But like I said in an opinion article last week in the Dutch Volkskrant, this is their virtual reality. This virtual reality has become their reality. Everybody accepts this, but it is very unlikely to be true. So for me, the pieces of the puzzle come together. Climate sensitivity is probably low. One of the speakers, Herr Poels, has explained extreme weather is not increasing. So we will probably get more warming in the 20th century, but it will be mild, it will be rather mild, and there will probably no increase in extremes. So a very minor, you cannot even say at the moment, in my opinion, that CO2 is a problem. It is a potential future problem. Thank you.